Welcome back, everyone. Today we will start talking about quadratic function. You guys know quadratic function has second power, so we will write down our regular general question, general equation like this, with some numbers in front of x's and a constant at the end. So we know from experience that it's going to be a parabola that goes up this way or goes down this way. And this concave up, I'll just write it as CU, concave down here. It really depends on A. If A is greater than 0, then you're going to get concave up. If A is less than 0, you're going to get concave down. Okay, that's the general form. And then, of course, parabola has a symmetry that right in the center, if you cut it, you're going to get a mirror image, right? Right in the center, if you cut it, you're going to get a mirror image. And those lines are vertical lines, so it's going to be x equals to some number here. X equals to some number that tells you the line equation. We call that line of symmetry. So let's explore more in detail here. So from ax squared plus bx plus c, we can tell the line of symmetry. It comes from, I hope you guys understand the logic behind this, but I'll just sum it up for you, that x should be minus b over 2a. So whatever the numbers in front of x squared, x, you use that to figure that out. And once the line of symmetry is set, right in the bottom or right on the tip of the top, you have the point coordinates, right? So of course, this coordinate has a special name. We call it vertex. And the vertex x coordinate is exactly same as the line of symmetry because it's where it's going through, right? So vertex has x and y coordinates. X coordinate is exactly same. And the other one is simply plugging in this thing into the function, that x value into the function. Your book has an explicit formula on that one, but I prefer to keep it just this way, but you could make it this way as well. So that's always going to be the case for you. And anything else do we need to know? There are a couple more things that we need to explore. Something like discriminant. This just tells you whether this parabola is going to cross x-axis in 2 points, or is it going to touch at 1 point, or is it not going to touch at all, right? So these 3 cases, we can tell it by discriminant, and it comes from b squared minus 4ac. But let me first make a note over there and then write these things down so that we could summarize later. So on a quadratic function, line of symmetry is given as, line of sim is given as x equals to minus b over 2a. And the vertex is given as that point with the x minus b over 2a and f minus b over 2a. And discriminant, which I will fill later, it tells you about the nature of x-intercepts, right? Whether you will have 2 x-intercepts or 1 or 0. So let me just make a mark here, b squared minus 4ac, and then I'll fill it in later. All right, let's look at some example here. So your book has a good example 1. But let me just come up with my own, and then we will deal with it. Example we have is f of x minus 4x squared plus 5x and plus 7. Okay, let's say we have this, right? This is my A, B, and C. So first thing that we will do, first line of symmetry. Line of symmetry would be x equals to minus b over 2a. In this case, it's going to be 5, and 2a would be 2 times minus 4. Let me just fill it in this form. And then take care of the minus signs. We get positive 5 over 8. Right? So here is the line of symmetry. And let's find the vertex. Vertex using the same x that we have, 5 over 8. And I'm going to put that number back into my function. That will give us the number, right? Okay, but one other form that we know here is 5